Hello everyone, and this is the video number 26 of UPSC Civil Service Mains Question Series, and today we will see one theoretical question of UPSC Civil Service 2020 paper. So define the term hardenability and which factor affects the hardenability. This is a 10 marks question. So it is the hardenability is the ability of the metal alloy is the depth to which the material is hardened after putting through a heat treatment process. That means suppose this is the total material depth, and suppose up to this height it is hardened. So the up to which depth which we can do the hardening by heat treatment process, that is called hardenability of the steel or alloy. Okay, so now let's discuss about, this is the definition. So now let's discuss about the factors affecting the hardenability. So there are basically four factors that affect the hardenability. First is grain size, then second is alternating temperature and the time for which we hold at that temperature. Third one is carbon content of the steel, and fourth one is alloying elements in the steels. So let us discuss one by one. So first is grain size. So grain boundaries are where two grains are formed, that when they started to form. So here this is the junction where this is called grain boundaries, where ferrite and pearlite start to form. And if this grain size is large, okay, so this boundary area decreases, so there will be a compaction effect. So there will be more hard grains formation of ferrite and pearlite. So as the and this transformation from ferrite and pearlite, this will be slowed down. So as the this compression takes place, so the hardenability of the steel increases as its grain size increases. So ultimately, in one line, if you want to say that, then hardenability of the steel increases as its grain size increase. Second factor is austenitic temperature and time. So the beneficial effect of the alloying elements in the steel increasing hardenability is realized only when the alloying element are made to go into the solution and to from homogeneous austenite solution. That means whatever alloying element you add, then the effect of on hardness you can only find when you heat it up to the austenating temperature. Okay, so what happens when you heat at up to austenating temperature, and you have to hold it for that some time to recrystallization of the grains and refine of the grain. So their new grain boundary forms, and this similar phenomenon that I've explained here, that will happen. So to understand, you can refer Jomini and quenching test. You can refer Jomini and quench test. That is the best example that gives the effect of austenatic temperature and their time. Suppose uh, if we keep too high temperature or too low temperature, or if it put this our object in austenitic temperature for too much time or too low time, then uh, there may be a less hardness or high hardness or hardenability, that will be adverse effect also there, so which result in bad effect. So in short, the austenitic temperature, we have to set the austenitic temperature based on alloying element, whether it may be carbon, chromium, manganese, whatever. We have to set the austenitic temperature, and we have to set a particular time for which we have to put that material in it, and then we have to cool down, or we have to do heat treatment to increase our hardenability. Third one is carbon content. So carbon fixes the maximum attainable hardness on the quenching. It also increases the hardenability of steel as it stabilizes in austenite. So whatever the carbon content, it should be stabilized in the austenite structure, which shifting the CCT curve. What is CCT curve? That is critical cooling temperature curve that we studied in TTT diagram. That is this C type diagram is there, and this is the critical, where the critical cooling curve passes through this nose. So then when it passes through this, then it gives the best results, and when it contains reaches up to 0.77%, that is the condition. But beyond that, hardenability decreases. Yeah, after adding more than carbon content in this, your hardness will increase, but hardenability will decrease. So at critical cooling rate and 0.77% carbon, and when stabilized in austenitic temperature, will give you hardenability increases. Then alloying element. So there are different alloying element which increase the hardenability, but hardenability sharply increases by manganese, and then chromium and molybdenum, and very small additional of boron, that is 0.0003 to 0.005%, and nickel as well as silicon have this effect, but nickel and silicon have very smaller effect. Okay, and this is are increased when this alloying element are added into steel. That means not a single element, but when the mixture of this alloying element, like some percentage of manganese, some percentage of chromium, some percentage of molybdenum, when we add and we do the heat treatment like this, alternating temperature and holding for that time and doing the heat treatment, then and only we can see the increase in hardenability of the steel. So these are the four factors of the alloying elements, uh, four factors which affect the hardenability of the steel. So this is the answer of the question. I hope you like this solution, and this is only for today. Tomorrow we will see some new videos and new questions on HL or maybe Indian Forest Service or maybe civil service. Okay, so stay tuned with us, and thank you for watching this video, and subscribe this channel for more upcoming content like this.